All right, so it asks us to solve each equation and to state the number of roots. Remember, when it says to solve the equation, that means for what values of x is the product here going to equal 0? Or in other words, what are the x-intercepts, because the y value here is 0? Or in other words, what are the roots? Those are all different ways of saying the same thing. So in example A, it's already factored for us. So all we need to do is think about the fact that here the product is 0, which means that either this binomial here equals 0 or this one does. So one of the two is going to equal 0. So I'm going to say, well, x minus 4 is equal to 0, or x plus 7 is equal to 0. Those are my two options or possibilities. And then I'm going to solve for x. So x minus 4 is 0. I'm going to bring 4 over to the other side, and I get x is equal to 4. Over here, I'm going to bring 7 over to the other side, and I'm left with x is equal to negative 7. So those are my roots. Those are my x-intercepts. Those are my zeros. And there's 2 of them, so therefore there are 2 real roots at x equals 4 and x equals negative 7. B. This one is also factored for us. Remember that when something is squared, that means that I'm multiplying it by itself. So r minus 1 times r minus 1. That's what it means. Here I'm using the variable r instead of x. That's okay. When I'm finding the roots, that means I'm looking for the x-intercept. So at the x-intercept, the value of y is 0. So I'm going to replace y with 0. And then, just as I did above, that means that either this equals 0 and when I solve for r is equal to 1 in both scenarios. So that means that there is only one real root at r equals 1. Okay, and what that would look like on the graph. That means that at r equals 1, there's just one root, and it's going to go up like this. So it's only going to cross, I know that looks kind of like a V, it's supposed to be a U, but it's only going to cross the x-axis once. Above, it'll cross it twice. So it'll cross it here, and it'll cross it here. Okay, this one is not factored for us, so it's going to require a little bit of more work for us. What we're going to do is we're going to bring everything over to this left or right side of the equation. I'm going to bring it over to the left so that this number is positive. So I'm going to bring this over, and that'll give me 2x squared minus 5x plus 3 minus 1 is equal to 0. There's nothing left on the other side. And I'm going to simplify, add these, 3 minus 1. So 2x squared minus 5x plus 2 is equal to 0. Now I need to factor. So I'm looking for two numbers that I can add together to get the middle coefficient of negative 5. And the same two numbers I want to multiply to give me the product of A and C, so 4. So I'm going to think about the factors of 4. 1 times 4. That doesn't work. Negative 1 times negative 4. That works. So those are my two numbers, negative 1 and negative 4. So I'm going to split or decompose the middle term, and instead of negative 5x, I'm going to write negative 1x and negative 4x. And you don't need to put the 1 here. I'm just putting it there to make it easier for you guys, but you can just write negative x. Now I'm going to factor this group here and this group here. I'm going to common factor. So 2x squared and negative x, the only thing that they have common is that they each have at least 1x. So that's what I'm going to factor out. And I'm left with, I'm going to divide the x out. And I'm left with 2x squared divided by x is x 2x. And negative x divided by x is just negative 1. Here, they don't have any x's in common, but they do have a 2 that can go into both of them. So I'm going to factor out the 2. Also remember that when the first number is negative, we factor out a negative number so that our bracket isn't beginning with a negative value. So I'm going to divide this by negative 2. I'm going to divide this by negative 2. This is from last week, so make sure you're going back if this is confusing at this point. Negative 4x divided by negative 2 gives me positive 2x, and 2 divided by negative 2 is negative 1. And I know I did it right because these two brackets are the same, so that's what I'm going to factor out. They both have a 2x minus 1 in them, so I'm going to factor that out, and I'm left with 2x minus 1. When I divide it out here, I'm left with x and negative 2. Now that I have it factored, I am going to think about my roots. So I have, I'm just going to highlight this so that this is what we're focused on now. So now, just like the previous example, I'm going to break it down and I'm going to say, okay, well, if their product is equal to 0, then that means either this equals 0 or this equals 0. And when I solve for x, I'm just going to do it in one step here because of space, but I bring 1 over to the other side and I divide both sides by 2, so I'm left with 1 over 2. It's just simple solving. And I bring 2 over to the other side and I'm left with x equals 2, which means I have 2 distinct, so 2 different real roots. So I'm going to say, therefore, there are 2 real roots at x is equal to 1 over 2 and x is equal to 2. And that just means that on the graph, I have one root at 0.5, and I have another root at 2. I don't have enough information to draw the rest of the parabola, but I mean I do. I'm just not going to go through it right now, but this is where my roots are. Last example. Here, you'll notice it looks a little bit different. It says 2x squared minus 18 equals 0. So in this case, I don't have a middle term. So I'm going to ask myself, okay, well, can I common factor? I notice that 2 goes into 2 and 2 also goes into 18. So I'm actually going to common factor my GCF of 2. I'm going to bring it out. Opposite of distributive properties, so I'm going to divide both sides by 2. You really don't need to do this step that I'm doing in the blue pen. I'm just putting that in case some of you are still following that step. Okay, so 2x squared divided by 2, I'm left with x squared. And then negative 18 divided by 2 is negative 9 is equal to 0. Now we are left with inside the brackets, it says x squared minus 9. If you remember from last week, this is one of our special cases that we factor. So our special cases there's two types. There was a perfect square trinomial, and there was a difference of squares. So x squared is a square number, 9 is also a square number, and they're being subtracted. So we call that a difference of squares. I don't know if that's not probably noticeable. Gonna have to invest in different color Sharpies. All right, so difference of squares. So remember, in order to do that, what I suggested last week was that you write it as the base squared. So in this case, I'm just going to ignore everything else for now. I'm just going to look at what's happening in here. I'm going to write it as x, because that's the base squared, minus, to write 9 as a square number, is 3 squared. I mean, technically I should be using square brackets over here. Okay, and then the trick to factoring a difference of squares, if we have a squared minus b squared factored, gives us a plus b times a minus b. So I look at the bases and I add them and then I subtract them. So here the bases are x and 3. So x is my a, 3 is my b. So I'm going to say 2 x plus 3, and then x minus 3 is equal to 0. Okay, so if that was a lot, go back to last week and review factoring difference of squares, maybe even taking a look at some of the extra practice questions. Okay, now this is now my factored form of the equation, so now I can use the factored form in order to determine what the roots, intercepts, zeros are. So I know that these three numbers are being multiplied to give me 0, which means that either this is equal to 0 or this is equal to 0. And when I solve for x, x is 3 or x is negative 3. Those are my two options. So there's two roots. There's two real roots at x is equal to 3 and x is equal to negative 3. So basically, on our graph, one of the roots is at 3 and one of the roots is at negative 3. All right, one more example. We have x, and then in brackets, 5x minus 2 is equal to 0. So this is also factored. I've factored out the common factor of x. The expanded form of this is 5x squared minus 2x is equal to 0. So what happened here was it's not a trinomial. All I was able to do was common factor, and that's where it got. So what I'm going to do is I'm going to say, okay, well that means this is my factor, this is my second factor. So that means that either x is equal to 0 or 5x minus 2 is equal to 0. It's really the same step as before, it's just that there's nothing being added to the x here. In this case, it's just by itself. So I need to solve for the x, so I'm going to bring the 2 over to the other side. Divide both sides by 5, and I'm left with x is equal to 2 over 5. So those are my two roots. So there are two real roots at x is equal to 0 and x is equal to 2 over 5. And what that would look like is, I made a graph initially, but I need to space it out more for you to see this. This is 1, this is negative 1. So I'm going up by 0.5s, just so that you can see that one of the roots is at 0, and the other root is at 2 over 5, or 0.4. So it would be over here somewhere. That's the second root. And then the parabola would be in here, like that.